Hello, this is Mr. Stein, and in this video, we are going to go over the questions from Mastery Items Week 12C. Number 1, determine the following using prime factorization. So GCF is equal to 3780 and 2730. So we're finding the greatest common factor. So we need to prime factorize these. And if you remember doing this, 3780, this is this process. We divide it by 2. We get 1890. Divided by 2. 945. Divided by, you can't divide it by 2 anymore, divided by 3. 315. Divide that by 3 again. 105. Divide that by 3 again. 35. Can't divide it by 3, but we can divide it by 5 and get 7. So 3780 is equal to 2 times 2 times 3 times 3 times 3 times 5 times 7. All right, so now let's do 2730. So 2730 divided by 2. We get 1365. We can divide that by 3 to get 455. Can't divide that by 3 anymore, so we divide it by 5 to get 91. We can't divide that by 5 anymore, so try 7. Divided by 7, get 13. So I'm going to just write this quickly in a different color. 2730 is equal to 2 times 3 times 5 times 13. I'm writing it in this specific way so we can easily see the greatest common factor. So we look at what they all have in common. They have a 2, a 3, and a 5 in common. So our greatest common factor is equal to 2 times 3 times 5. That's what they have in common. All right, now we're going to find the least common multiple of 132 and 330. Fortunately for us, these are a little easier to prime factorize. So let's start with 132. We can divide that by 2 to get 66. Divide that by 2 to get 33. Divide that by 3 to get 11. So 132 3 times 11. And now let's do 330. We can divide it by 2. $165. We can divide it by 3. 55 divided by 5, and we get 11. So it's equal to 2 times 3 times 11 times 5. All right. Now I did it in a little different order so that our numbers would match up. Now our least common multiple, I'm going to erase these two guys here. Our least common multiple has to have 1 2 in it, 2 2's in it, because it has to have all the 2's from 132, so it has to have 2 times 2. It has to have a 3 in it, and an 11 in it, and a 5. So that is our least common multiple. 2 times 2 times 3 times 5 times 11. So whatever number that turns out to be. Because inside this number, we have to see all the factors from 132 and all the factors from 330. We want the smallest amount of factors that have all the factors from 132 and all the factors from 330. All right. Simplify the following exponents. So we've got the square root of 9 x to the 4th y to the 6th. Now we just can square root each one of these terms individually because it's all multiplication underneath the square root sign. So the square root of 9 is 3. The square root of x to the 4th, when we square root, we cut the exponents in half. So it's going to be x squared. And y to the 6th It's going to be y cubed. When we square root a variable with an exponent, we cut the exponent in half. All right, let's take a look at this guy here. Letter B. We've got one of these fraction guys again. Unfortunately, in this fraction guy, we've got this negative exponent. Now, the negative exponent tells me to move it to the other side of the fraction line. So I'm going to rewrite this. It's 2 over 10. And now this x to the minus 3 moves to the bottom and becomes x to the plus 3. So we've got So we got x to the plus 3 times x to the plus 3. So we get x to the 6th on the bottom. Y squared over y to the 6 on the bottom. All right, so let's simplify a little bit. So it becomes our coefficients becomes 1 over 5. We still have an x to the 6th on the bottom. Now the y's, we cross off 2 y's from the top and we cross off 2 y's from the bottom. We'll have y to the 4th on the bottom. So it's 1 over 5 times x to the power 6 times y to the power 4. All right. Use the following function, h of x equals x squared plus 5. Determine the following. So we want to determine the function h evaluated when x equals 3. So h of 3 is equal to 3 squared plus 5. It's equal to 9 plus 5. It's equal to 14. Now this will give us the point on the graph when x is 3, y will be 14. That's one of the points on the graph. The graph is just all of the pairs of numbers that satisfy this equation. Now in this one we have h of x equals 30. Now if you remember, that means we replace that h of x with 30. So we get 30 is equal to x squared plus 5. Take 5 away from both sides to get 25 is equal to x squared. And x is equal to the square root of 25. Now, this can be the plus or minus the square root of 25. So x could equal plus or minus 5. Both of them. I'll show you why. If I take this and I put plus 5 in it, if I do plus 5, h evaluated at plus 5, I will get plus 5 squared plus 5, which is equal to 25 plus 5, which is equal to 30. That's plus 5. I got my 30. Now, if I do h evaluated at minus 5 is equal to minus 5 squared plus 5. Minus 5 squared is also 25 plus 5 is also equal to 30. So minus 5 will also give me 30, plus 5 will also give me 30. That's why there's two answers to this. It's because it's a squared function. All right. I hope that was helpful. And if you have any questions, please put them in the comments below or